For my Strive project, I coded a cardioid by joining points across the circle in a specific pattern. This required the mathematical concepts of congruence, modulus operations, and converting Cartesian points into polar coordinates. Hi, my name is Mia, and I'm in 9th grade, and I'm a student at Singapore American School. One of the most amazing features that emerges from this code is the heart sort of shape, which can be referred to as a cardioid. Cardioids show up everywhere. The word cardio refers to anything in the shape of a heart, because the organ is a cardioid shape. You can even see one by looking into a half-empty mug in a bright environment. To do this, we first number n points around a circle. In this case, n equals 5. Then we pick a multiplication factor, in this case 2. Then we start connecting the points with the following pattern. Starting with 1 times our factor, 2 equals 2, so you connect 1 to 2. Now 2 times our factor, 2 equals 4, so you connect 2 to 4. Then 4 times our factor, 2 equals 8. Since there is no 8, we take the modulus of 8 in n. In other words, we take the remainder of 8 when divided by n. So 8 divided by 5 gives us a remainder of 3, so we connect 4 to 3, and so on and so forth. Using a for loop, you can keep increasing the n value. This gives us these beautiful patterns, and slowly the cardioid emerges. I can quickly change the number of points on the circle because each point is labeled and graphed using polar coordinates. By rearranging the equation of a circle, I can calculate the x and y value of each point. Something that I really enjoyed about this project is that I actually learned these concepts in school previously, so being able to apply these immediately in the real world was really interesting. Another thing that I learned was how to use trigonometry to make evenly spaced out points on a circle. Now I really enjoy coding because I can basically do anything with it.
Every parent knows that trigonometry is terrifying for students, mostly because they struggled with it when they were young. Mia has shown us through her project that she has an in-depth understanding of trigonometry because she could use the concepts to create this beautiful visualization. Students who can recite the formulas of sine and cosine are plenty, but Mia understands why they're important and how they can be used, and that's what sets her apart.
As you can see here, sorry.
No, skip that, you can see here.
The word specific points across a circle in a specific pattern. That's not how it's supposed to sound at all.